Every platform engineer, every developer, they sort of live with this background hum of anxiety, right? That fear an update breaks the build, or some vulnerability is lurking deep in the supply chain. It's this constant balancing act, speed versus safety. That's just the reality of CI/CD today. So today, we're doing a deep dive into the SonarQube Server 2025.5 release, our mission, to pull out the really key things that help you, whether you're coding fast, hardening pipelines in DevSecOps, or maybe managing the whole platform. And it's important to note, this isn't just us reading release notes. Our analysis is informed by some great operational insights from ALM Toolbox. They're an official Goldie partner of SonarQube, so these folks are really in the trenches. They help companies apply SonarQube best practices, integrate it properly, handle upgrades. Basically, they live this stuff.
That's right. And looking at it from that practical deployment angle, you can really see three main themes emerging in this 2025.5 release. First, boosting security, especially around the supply chain. Second, improving productivity, really cutting down on that developer toil or frustration. And third, enabling better enterprise governance and compliance. Maybe we should start with that first one. Security, it's always top of mind.
Definitely. The source material talks about a monumental leap forward in security. Supply chain defense seems key. So where's the big change happening there?
Well, what's really interesting is how they're shifting left, like really left-right, into the CI/CD definition itself. SonarQube now directly supports analyzing GitHub Actions YAML files.
Okay. So not just scanning the code after it's built, but scanning the instructions for the build.
Exactly. It's looking for security misconfigurations, potential vulnerabilities right there in the pipeline's DNA, you could say. The rules that control how everything gets built and deployed.
That feels like a significant reduction in the potential attack surface. Finding risks in the configuration, not just the final artifact.
So what kind of specific threats are we talking about? What if someone, accidentally puts something risky in that YAML?
That's precisely what these new rules are designed to catch. They're quite specific. For example, Rule S7630 looks for script injections within the workflow itself, and S7631 is crucial. It flags checking out code from an external fork inside a workflow that has high privileges. That's a classic supply chain risk.
Yeah.
And also, improper secrets handling, like S7636 catches if you accidentally expand secrets within run blocks where they might get logged or exposed.
Okay, locking down the pipeline definition makes sense. What about the analysis engines for the code itself? Are they keeping pace, especially with languages like JavaScript?
Yes, definitely keeping pace. For JavaScript and TypeScript, the big news is the next-gen taint analysis engine is now the default. And this matters because it promises better accuracy and speed, which directly means fewer false positives. Right, less noise.
Yeah.
DevSecOps teams aren't spending cycles chasing down issues that aren't really there.
Exactly. More confidence in the findings that do pop up.
And I saw something interesting that feels a bit maybe overlooked sometimes. Desktop apps, specifically .NET WPF. Why focus taint analysis there now?
Well, risk isn't just web apps, right? Lots of organizations still have critical internal tools built with .NET desktop tech. So the taint analysis now understands WPF entry points, UI controls, data bindings, command parameters, things like that. If potentially unsafe data comes in through those routes, SonarQube can now track it to see if it hits something sensitive like a database query, find those injection risks.
Okay. So it's providing consistent security coverage, whether it's a cloud service or a traditional desktop application, closing potential blind spots.
Precisely, ensuring that consistency across the board.
Closing blind spots is key for security. But let's pivot to the developer and maybe the platform engineer experience. If security is step one, step two has got to be making life easier, reducing that friction, that toil. And maybe the biggest headache, like we mentioned up front, is when the tool update itself causes chaos.
Oh, absolutely. And the solution here, this combination of non-disruptive updates and the new sandboxing feature, is honestly game-changing for administrators. Think about the old way admin updates SonarQube. Maybe for better security rules, good intentions, right? But suddenly, the new analysis finds a bunch of new issues, maybe minor stuff, but enough to fail the quality gate. And boom, every developer's pipeline turns red. Chaos.
Right, instant bottleneck. So how does sandboxing fix that? Does it just hide the new issues?
Not hide, but manage. It's actually quite clever. Issues that are only appearing because of the SonarQube update itself, because of a new rule or an analyzer improvement, can be put into the sandbox. They're visible to the team, flagged as new due to the update, but they don't immediately fail the quality gate if certain conditions are met.
Okay, so the build stays green, developers aren't blocked.
Exactly. The team sees the new findings, they can triage them, understand why the new rule flags something, maybe adjust their code, but they do it on their own schedule. It turns the SonarQube update from a potential crisis into just a managed maintenance event. Huge relief for platform teams.
That really does sound like it lowers the stress levels significantly. Okay, stability covered. What about raw speed? Python seems to get a big boost.
Yeah, this is a straightforward productivity win, especially if you have large Python code bases. Python analysis rules can now run in parallel. The analyzer can use up to 6 CPU cores, leveraging, up to 90% of the available power on those cores. So multiple files get analyzed concurrently.
Which means faster feedback for developers waiting on those scans, especially on big monoliths, I imagine.
Absolutely. Shorter wait times, faster iterations.
And sticking with Python, I saw a specific focus on something very modern and cost-sensitive: AWS Lambda, serverless functions.
Yes, there are new specialized Python rules just for Lambda, and they're really focused on efficiency, reliability, and saving money, frankly. They target common serverless pitfalls, like there are rules to help you avoid patterns that lead to unnecessary cold starts. Or S6246 flags inefficient things like synchronously invoking another Lambda function, which can really slow things down and cost more.
Yeah, waiting around in a serverless function sounds like the opposite of the whole point: costly waiting.
Exactly. And other rules push for best practices that have direct cost implications, like S7620 reminds you to clean up temporary files written to temp, which can accumulate. Or S7635 flags if you're embedding long-term AWS access keys directly in the Lambda code. Big security and operational risk there. It helps enforce standards that are about being cloud smart, not just correct code.
That's a nice blend of governance and practical help for developers working in the cloud. Okay, yeah, before we leave productivity, quick mention of web development. Angular got some attention too.
It did. SonarQube's finding more issues in Angular code now, particularly outside of the component templates. The idea is to nudge developers towards more modern Angular patterns. For example, Rule S7655 encourages classes to actually implement the lifecycle interfaces, like on init if they use the corresponding methods, makes the code clearer, and another rule discourages using aliases for at input and at output bindings, which can sometimes be confusing, just keeping the code base clean and aligned with best practices.
Right, helps maintain quality without needing yet another separate linting tool, maybe. Streamlining. Okay, that naturally leads us to the third big theme: confidence in governance and compliance. This feels like where platform engineering and leadership get more direct control.
Absolutely. And the first big item here is crucial for certain industries: expanded support for the SRA C++.2023 guidelines. SRA C++ is basically the standard for safety critical systems. Think automotive software, medical devices, aerospace. Being able to detect compliance issues with the latest standard early in the development cycle is massive for getting those products to market faster in regulated fields.
Makes sense. Nail down compliance from the start. Okay, besides specific standards, what about controlling SonarQube's own features? I saw something about software composition analysis, SCA.
Yes, this is a really significant change for administrators managing large SonarQube instances. SCA activation used to be kind of an all-or-nothing thing at the instance level. You turned it on and bam, it hit all your projects.
Which could be disruptive, I imagine. Suddenly, thousands of vulnerability reports appear overnight.
Exactly. It could be overwhelming. Now it's much more granular. Admins can set a default. Maybe SCA is off by default for new projects, but crucially, they can then enable it selectively on a project-by-project basis.
So they can pilot it with one team, see the impact, figure out the remediation process, and then roll it out gradually.
Precisely. It allows for a strategic, controlled adoption, puts the power back in the hands of the platform or DevSecOps team to manage that rollout smoothly without having to manually tweak, build pipelines for projects they want to exclude temporarily. Much less operational pain.
Okay, controlled rollout. And finally, there was a smaller, but maybe quite useful operational improvement: global announcement messages.
Yeah, it seems small, but it's actually pretty neat. Those banners you see at the top of SonarQube, maybe announcing maintenance, they now support Markdown formatting and, importantly, clickable links.
Oh, so you could link directly to internal wikis or support docs or policy pages?
Exactly. It transforms that banner from just a passive notification that people might ignore into an active communication channel. You can guide users directly where they need to go, could really streamline internal communication and cut down on repetitive questions.
That's clever, turning a simple banner into a real tool. Okay, so We pull all this together. This 2025.5 release really feels like it's about giving teams more control, more speed, and more confidence. Control over updates with sandboxing, speed from parallel Python and faster JavaScript analysis, and confidence that your security checks cover everything from the supply chain via GitHub Actions right down to .NET desktop apps.
I think that's a great summary. The real benefit, if you're listening, is getting that faster, more accurate feedback loop for developers, while also giving administrators the tools to manage updates and feature rollouts without constantly worrying about breaking the CI/CD flow for everyone. It's about enabling continuous improvement without continuous disruption.
And of course, getting the most out of these features, integrating them smoothly into a complex environment. That takes expertise, which is where, as we mentioned, companies like ALM Toolbox come in, helping apply those best practices and manage the SonarQube environments effectively.
Right. And that actually brings up an interesting final thought for you to chew on. We've talked about features like non-disruptive updates and granular SCA rollout, giving more control back to platform engineers and admins. So the question becomes, how does this increased level of governance, this ability to manage the tool's impact so precisely, actually shift or redefine where the ultimate responsibility for software quality and security lies across that entire modern development pipeline from the first commit all the way to production deployment? Where does that responsibility truly begin and end now?